All right, everybody, welcome to day four. Um, we're going to be covering unordered data types today, but I'm going to take a little um, moment to go over a kind of a handy little tool that'll help you with trying to solve the problem that you come into when you're running into the exercises, assignments, and that sort of thing. And this will also be helpful for the three questions that you end up the three programming challenges that you work on to be able to submit the Code Platoon application. So this is called an IPO chart or an input processing output chart. So what you use this for is you kind of use this to help break down the problem. So this is not a problem from any of your exercises or anything like that. Um, our this particular example, we're going to just walk through it really quick to see how you would use this. So our challenge here is to write a program that reads in hours, minutes, and seconds as input and outputs the time in seconds. Well, I know we haven't gone over how to get input. So how else could we get that information? Anybody, just fire it off.
Use W3.
Use W3? What do you mean?
Yep. So if you don't know like how to write the code in order to, accept input, you can like look up like I guess the input function.
Well, you could do that, yes. But in this particular case, we could just use variables, right?
Gotcha.
Yeah. So instead of worrying about the input functions, that's what I was trying to get at. We could use, given the stuff that we've covered right now, but that's a very good point, is when you know it's a thing, you know there's a way to get input from a user, but we haven't covered it yet. You could go check out W3. You could check out all kinds of resources to be able to figure out what that function would be. So effectively, obviously the input column is all of the pieces of all of the known values or the known values or anything we would need to get from the user. In this case, we're going to use known values or variables. The processing is exactly that. It's the step-by-step process, how we're going to take that input and get to the output. And the output is what we're supposed to read back to the user, what is supposed to be displayed to them. And you want it exact in this particular instance. So I'm going to start it out. Well, anybody want to take a shot at what the input when we're dealing with variables, what we would put into this section right here?
Your variable equal to
Make
your
make sure you read the problem.
which problem are we on?
This one right here. I've got it right here.
Uh,
So this is the problem we're working on right here.
Would it be something like time?
Well, that's a bit that's a bit
would it be
time is used here, but not as the input. The total time would be
would
used
it var-
as,
so something variable equals hours?
well, right here we're looking for just the variable names. So let's roll it this simple. That this is the part about this is trying to keep to the simple thinking. We are not worried about code at all right now.
So
This is not done in code.
variable hours and then equals one.
Nope, just the name. That's all we need.
Okay.
And then what else do we need?
Seconds. Minutes, I'm sorry.
Yep. All right. Do you see how that works?
Yeah.
Yeah.
Now, Josh mentioned in chat, should we consider the conversions from hours to minutes to seconds? Where do you think that information is going to go?
Processing.
Processing part.
Exactly. So what we do is we go through and we're breaking this down Barney style. So I mean, every single piece. In this particular instance, we
60.
assign hours. It's so this means that we're declaring these variables. So let's I don't know. Yeah, so I've got an example here. So we'll go hours equals 1.
Oh.
6. I'm just giving from, I have a side example, so I'm just punching these numbers in here. There. So, and we're only doing that because we're dealing with variables. If we were getting the input, this, instead of saying assign hours equals 1, it would say get our input from user. And then same thing with minutes and then seconds. So now we're breaking this completely down. And Josh is on the right track. 1 hour equals 3,600 seconds. So that right there could be the first process, the first part of our calculation, or the first part, the next part of our processing. And then what I would do is just like he's put in chat, put the logic there. And this right here should be wrapping. Let me. There we go. For reference, it's nice to be able to add your step numbers inside the processing chart. So what would then go
I
ahead?
got a quick question. So, like, when you're inputting all this, like, for example, like for if statements or LF statements, you typically want to start with the lowest, like, integer. Why is it with this that, like, we'll start with kind of the highest being like an hour and not like seconds, minutes, and then hours?
Okay, so what is our output?
In seconds.
So our
Yeah,
output.
time in seconds.
So what do we need to do to the seconds?
Okay, I got it.
In this particular case, we don't have to do anything to the seconds. So what do you think the next, what would step 5 be?
Calculate.
Calculate seconds from minutes.
There we go. And again, you put your
60.
logic right in here. Yep.
I'm probably trying to skip ahead by asking that, but I'm just curious to like what the outcome is.
So now, what is the next step?
You probably have to combine all the seconds together.
And this is the reason why it's nice to number these, because you can go
6, 3, 4, 5 to get total seconds.
because now you're referring to how you've numbered out your little blocks here. So what's the last step?
Total seconds.
What do
Print total seconds.
Display. Oh,
We're not even thinking about program syntax at all. And then let's see here. The places where you would put your variable names would be in the input and the output sections.
Why in the output sections?
Because these right here help you track. This is where you're thinking about. These spots are where you're thinking about
What
what
would
your
be?
variable, what makes sense to call your variable names.
Okay.
Is that helpful for everybody?
Yes.
I've seen this tool used a lot for working through other little problems and stuff like that. And it's very, very easy. You usually want to like right here, take a cell in your Excel sheet, whichever sheet you're using, and paste the problem. Then mark out your 3 sections: input, processing, and output, and then break down your problem into all of these pieces. A lot of times you can start with your input and then put your output so that you've got identified those 2 pieces, because those are that's the low hanging fruit. That's the easy pieces. And then work through step by step the processing. But notice how we didn't use we're not writing any code. We're not thinking about if statements. We're not thinking about any of that.
What is the process that this would be used for? Like I'm just having a hard time trying to like imagine like a situation that this would be used for. Like what would you use this for?
To get total seconds? Okay. So which is easier for building a delay into a program, giving it seconds or converting all of this stuff each time?
Probably seconds.
Yeah. So that's where, like, knowing the 3600, we can do the math to break that out. But usually most of your delay functions deal in seconds. So you might want to, this might be some sort of sub function where you're not even getting let's say this isn't even getting the information from the user. It's pulling it from a timestamp somewhere. And then you're trying to process with it. So you break it all down to the seconds so that this computer can do its processing easily. There are other ways to deal with dates and times and stuff, but at the stage we're at right now, this is probably the easiest way to think of it, and it's a pretty simple problem.
Yeah.
So the main point of this is something that's relatively easy to break down into the processing steps, so you can kind of visualize how this is done, and then you can kind of take that and apply it to your exercises, or you can apply it to the
So
code.
basically just like so forth where you would need breaks and you would already have the calculations like outputted for you.
Yep, it's all right here. So it's an easier way to reference through, because so now you've done your thinking here. Now you can start thinking syntax.
Gotcha.
You're kind of compartmentalizing where your process is going.
Understood.
All right. Any questions? Comments? All right, I'm going to shoot that off to the side. Everybody remember how to start up code spaces, right? Make sure. You can go ahead and start your code spaces if you haven't already. And while this is loading, I've seen now that IPO chart is not something I came up with. I've seen it in a lot of different places, and it might look new. And I know I believe it's sometime last week someone was asking about how would we work through, trying to solve these problems and stuff. And that's one of the tools. It's one of the ways you could do it. You could also take a notepad and just kind of scratch stuff out on just on a sheet of paper, whatever's comfortable for you. There's tons and tons of tools out there, but not every tool's made for every person. So, all right, so we are in close these out. So today we're covering unordered data structures and the methods, just like we were talking, just like we went through lists and tuples. These are similar to those. Now, the list and the tuple, they're in an order, so they're called ordered collections. So they're always in that order. That way, you can access the index of a tuple or a list, and it's always the same. It's always the same value. With sets and dictionaries, they're unordered, so they don't always fall into that order because the index is not how you access these. So sets they're mutable, they're ordered. It's a collection of unique elements. That's a really important piece to understand is you cannot have duplicate values inside a set. This creates an empty set, and we're not in our kernel. If Jupyter Notebooks forgot what your kernel was, just remember you'll see select kernel up here, and you can just click that. You should be able to get your drop down, and you're looking for the one that's in, what was it, user local bin. So this right here, this declares an empty set. And this was the issue we were talking about before, where we should get used to having these surrounded inside the print. In this particular situation, it should still display the set with parentheses. Verify, this should be fine. So if we run this, we get the set right here. Now, if you want, you don't have to declare the set as an empty set. You can declare a set with values. So when you initially create the set, I'm going to print this here. If you already know the values you want in your set, you can initialize them with those values. Now it has the curly brackets on the outside instead of the parentheses, where the tuple would have the parentheses and the list would have the square brackets. The set has the curly brackets and each value is separated by a comma. So it looks very similar. And printing it out should look pretty much like what you've inputted here. Any questions with that?
Yeah, real quick. When I'm printing this thing out, it's not showing in my terminal, and like it's showing at the bottom, your bottom terminal.
Okay, over here.
Yeah, and see, I noticed that you have yours is Python down to the lower right, but mine has Bash for some reason.
Ooh, that's not. Yeah. Is
Yeah,
the practice file a .py file? That would be
which file?
important. Your practice file, see how that's. You said you were doing this with
Oh, right
VS
there.
Code, right? Yeah.
Oh, yeah. No. That's when I practice alone, and I don't open up my code space, but I have my code
Okay.
space open now. Yeah. You know what?
What does it
Whatever.
say? What does it say right up here? Does it say select kernel or does it say something else?
Yeah, it says the same thing yours does.
But running this,
Yeah, that then yeah, and it pulls up something totally. I think it has something to do when I was trying a coding, like a quick coding class before, and that's how I set everything up initially with VS Code. But um,
are you using your VS Code or are you using the Code Spaces one?
code spaces.
So the Code Spaces one should already be set up to work properly.
Oh,
We can look at that later.
yeah,
Can
yeah, that's
you
fine. That's not a problem. I can still follow along. It's not like it's still doing everything.
you can create the practice PY file and that should hopefully pull in the right interpreter.
Okay,
Oh, um, yeah,
that's
and
fine.
make sure that it says Python over here on the right
Yeah, it
too.
doesn't. That's why I was saying
Okay.
earlier. It doesn't say that, but we don't have the slow class now for that. I can follow along.
Okay, yeah, and we'll have a look at it when we have a break or something. Okay, so I'm gonna move this over here so you can see that, or copy this over here so that you can see that this runs the same inside the terminal as well. So there's your set and there's the definition. Okay, so what do you think is going to happen in here? Remember, the set is unique values. So what do you think will happen here?
You're going to receive some type of error message since you have duplicates.
Well, so you know that they can't have duplicates, but will it give you an error message?
Will it add like all of the sums?
Well, how about we hit the play button and see here? So it's not really an error because it's not a bad value. But it also does not add them. So it automatically deduplicates values. You can, this is kind of like, you can use this as a shortcutted way to remove duplicates from something. With extra processing and that sort of stuff and some of the other techniques that we'll see in like Thursday's lesson and whatnot. But sets are a pretty handy thing for removing duplicates and that sort of thing. Any questions?
You're saying like removing duplicates, like in what situation? Like my thing is like always a situation, like trying to piece together like how this would work with something.
What situation? We'll hold on to that because the next data structure is a place where I have actually used sets to be able to build the next data structure before.
Okay.
So Adam's asking if this is a typo where it automatically removes. It says it should, I believe it should say remove. This says deduplicate, which is, yeah, it should, I agree with you. It should say automatically remove duplicates just to make that a little more clear. Let me make a note of that. Thank you, Adam. What is this? I agree. Yeah. It should
Yeah.
definitely say remove duplicates. It flows quicker and easier. So yeah, there's no errors. It just ignores the duplicate values and just keeps moving on. Whereas you could see the tuple, That took every value because you can have duplicate values there. Any questions there? All right, so we have similar methods inside sets as we do lists. You can use an add. Well, so there is no append because there's no order. So all you do is just add the element. You can remove by using the similar syntax as what we used from lists. But when you're adding and removing these elements, you're referring to the actual element value. So this code block right here, let me add this print in here. We'll add the number 500 to our mySet variable. And now you see how it didn't just add it to the end, it just throws it in there. So it's a key thing to remember that these are not in any particular order. Sometimes you'll see it if you run it again, the items will be in different spots or something like that. We're not going to continue pushing the button until we find that. With the remove, you're again supplying the value that you want to remove. Add the print here. And as we see, the 500's gone. This particular, okay, so top removes and returns a random item. So do you guys remember what this was? What kind of data type? Never mind, that's not creating a data type. So when we run this, we have our first variable listed as item, which is this is the variable that it's removing. And then this is what is left with the set. Everybody see that? Any questions there? Yes, Josh. Josh, pop removes and returns data, but it's a random item from the set. Okay, so there are some other methods that deal with sets where you can use for comparison between two sets. Now this right here, let's see if we can, I'm going to try to close out and move some of these things around. All right, can everybody see that very well? So this is usually when you're trying to compare two sets, and I haven't used these methods very often. So it's something that it's good to know that it's a thing, but definitely, like I said before, a lot of these things aren't things that you're going to end up memorizing or whatnot. But we do have the methods, intersection, which shows what elements in set A, which set A is what we're using to call, and set B, which is inside the parentheses. Everything that both sets have, it will return that information. Okay, so the intersections displayed down here. We'll cover that after we cover. We'll go through this really quick and then we'll try to run back. We'll refer back up top here as we go through the exercises, the examples here. So a union takes everything from set A or set B So basically, any duplicates, it will remove them, and you get a combined set of both sets. Does that make sense?
Yes.
Okay. And then the difference, oh, these have mathematical operations if you're familiar with them. I'm not gonna lie, I don't remember these, and awesome if some of you guys do, but that's what's great about having the visual representation right over here. So a left set difference would be you want the elements that are in set A that are not in set B. So this is set A on this side. We have set A and then set B. Oh, that's going to be terrible.
So that's the equivalence of like from when we were in like lesson 2. I forget what the command was for. It's like reading past the parentheses or on the left side of the parentheses.
Oh, so are you talking about how we're calling it?
Yeah.
Yes. So this is our data type, which is A has already been declared as a set. So like right here, we've already declared this as a set. So we would call my other set dot difference. And then in the parentheses where B is, that would be like my set. And there's examples of these as we go down through. So we'll actually see some of the variable names.
Okay.
And then if you reverse the variables, you reverse the difference. So it's effectively, it's still, you can use either image because if you look at this with the B, if you flip the other image where this is, they're effectively still doing the same thing. That's why it's the same function. All you've done is move where the variables are. Does that make sense? Or did I make it more confusing by trying to explain it that way?
No, that makes sense. I was just making sure it was like to the same concept of like what we learned. I think it was in lesson 2. It's a
Yes.
different
And
variables.
that's the that dot starts calling the methods. So like when we were talking about our string method, we have our variable my string, and then if you put a dot upper with parentheses, you're calling that method that makes the whole string uppercase. This is the same idea as these methods exist inside the set. So if I were to go like this, if I want to see what, there's a lot more than what we're covering here, but you see, here's all of those methods, just like we saw with the string.
Yeah.
Okay, clear that out. And then there's the symmetric difference, which is effectively it's what is not shared by both elements. So whatever is not in both elements, A or B, A and B, is returned. So it gives you a set of everything in the blue. So here we're just creating another set for these.
10, 3, 4.
And now here's the, okay, so we've got the my set. I'm going to add, so we see here. So now we have both sets right here. So now we're going to run the union, and we need to add a print to this. So that now what you see is, as we saw with the union, it returns everything. So we take all of the values and then remove duplicates, and this is the contents of both sets without duplicates. Any questions there? Same is true for the difference. So with difference, we're calling my set first and my other set. So when we're looking at difference here, the blue is my set. Everything over here is my other set. So we get just the results that are in my set with nothing shared. Any questions? And here's the my symmetric difference. Add the print. And as we see here, my symmetric difference was everything that was not shared. So effectively, the difference, no, that's not what we want. We want the intersection. So the intersection, I'm going to try. So this should be, if you look at this, this is everything that is not in here. You see that? I don't know what's going here. Any questions with these?
No, I'm gonna have to read back through this. This was a little bit more confusing than the loops.
Yeah, it takes kind of looking at it might be easier to take and like take this sheet or this web page and side by side them.
Yeah, for
when you're
sure.
working with stuff. So then you can constantly look at your graphic here and start working through your problems here.
Totally.
And this is a concept that SQL uses as well. And I'm not going to lie, I always have to try to refer the diagram to remember what's this do, what's that do.
That's kind of what I've been doing, because after a day of like playing with loops, I got the understanding of loops. I'm probably gonna have to do the same with this.
And that's why that's the key concept or key. There we go. That's one of the cornerstones of programming is practice. Just get your hands into it, play with the stuff, and see what's going on.
Yeah.
And the graphics are kind of helpful, but Dominic, you said when you printed yours, it's not defined. What part are you referring to? This section right here, the bottom one? Okay, so if your set is saying that it's undefined, come back up to where the set is being defined. I would do it right here. If you run this, you'll get your set. Because right here is the first. This is the last time it said my set equals this. So this is the last assignment. And this is the one that you want that will bring your set into memory. Because you have to, if you skip running a code block, then in the Jupyter Notebooks memory, that set doesn't exist. So if you run that and then come back down and run these, it should be fine. Yep, no problem. That's another reason why I like running the practice file, because then you make sure that you're declaring everything. Okay, so this is assigning two sets. So we'll run this. So now we have these two sets in memory. And now it's going to, we're running a difference, and what we want to do is we want to add print here. And this is going to run the difference of which employees who still need to complete their annual training. So what we're looking for is the difference. So if we jump back here, we look at the difference. We want the elements from the left side, so A, and not the shared pieces. So the left side is all of the employees, and the right side is the employees that completed training. So the purpose of this is we're looking to see who still needs to complete their training. We run this, and these are all of the names who did not show up. Yeah, most of them. That's usually the example with training, right?
That was a better example for me.
Okay.
Like
Okay, good.
now that I can
Yeah.
see like it in function. Because with the numbers, I think it was pretty confusing for
They
me.
can get convoluted when it's all jammed in there. Yeah, this does have a better use case for it. Yes, this
What do
is
you
like,
mean we say left and right side? That was a little confusing.
okay, so the left side in this example, our left side is employees, our right side is completed training, right? So what we do is we roll that back up. Well, we'll keep it here. And we're looking at this section right here. So the A is the left side. Oops. A is the left side. And B is the right side.
Okay, I see what you mean. A dot difference.
Yes.
B.
Yes. And that's why when I was talking about this, even though the picture looks backwards, the picture looks backwards because the variables are flipped. So all this is just moving the variables.
In terminology, I don't know necessarily how to ask the question that I want the answer to, but in terminology, so you would be calling for a dot difference to give you B.
A dot difference, what you're trying to do is you want to filter out, you're trying to filter out anything that's in B.
Okay. So
Yeah.
you're calling for a dot difference and then you're filtering B.
Yes.
Okay. I just want to get like the terminology because I understand like more or less what's going on. It's just terminology. Did I freeze here? What happened?
No, you're good. I'm making a note of that. I apologize.
No, you're all right.
That's a good way to clarify is it's filtering them out. So this is like running a filter on your sets.
Yeah.
So yeah, in this, in this example, we're taking all the employees and we're filtered out who's completed their training. So now we have who still needs to.
Yeah.
And Josh, I see you were having an issue with the employees. Did you get that fixed? So you need to run this block right here, and that's what defines the employee's name, and then you can run this block. The way Jupyter Notebooks works is if you skip running a block, then it doesn't add this code into memory. An easy way you can double check is you can look for you should have a checkbox next to the stuff that you've run. And this is just a nuance of Jupyter Notebooks. If you were to copy this section into your practice.py, it might be a little more evident to you that completed training and employees was not defined. So to be able to run this in your practice, you would have to copy both sets of code for this to run.
That was some of the problem that I ran into. You have to define a lot of the variables.
Yeah, they have to be in there because if it's not in there, and it's kind of easier to see that, I don't have anywhere in here that says employees. Everything is commented out, so effectively nothing exists inside this file right now. So if I
Yeah.
try to reference a variable that I haven't defined, then it will give me
It's not going to print anything because it's all comments.
well, it will print an error
Yeah.
because I'm trying to reference a variable I never
Never stored.
stored. Yeah, I'm trying to reference something that just isn't there.
Gotcha.
Okay. Any more questions on sets? Okay. I'd have to say the next one, dictionaries, is probably one of the data structures that I use quite a bit. They're very, very handy. I believe in most languages I've dealt with, I think dictionaries happens to be one of the things I use the most when I'm organizing data and doing just processing through things and whatnot. Naturally, we know strings and our various number types are very important, but a lot of this is a way to kind of put them together and give meaning to stuff in my head anyway. So dictionaries are mutable, they're unordered, but these are key value pairs. So the set is a sequence. This is a sequence. This is a sequence here, and you access them by their actual values. Dictionaries have keys and value pairs. So your keys can be of any immutable type. So strings, numbers, and tuples can all be keys in a dictionary. And I know that this is kind of a bit confusing. What you can see here when you look at the information on the driver's license, that's a example of key value pairs. So what I mean by that is you have sex and female, height. There we go. Sex and female, height and a value, key, value, key, value. Does that make sense? Any questions there?
So I mean, in sense, we would be calling like sex the variable and like female the
Sex is the key.
this key.
This is the key. And then that's the value.
Gotcha.
Okay, so on a license, sex is on every single license, right? but not
Yeah.
everybody's female. So the sex is the item that we're looking for, and the female or male is the variable or the value for that particular license. So this whole license could be turned into a dictionary. You just take everything that's in the red, and those are your keys. And I'll show you that in a minute here.
That was a little confusing, but I get what you're saying.
So we come down here. This is okay. So this right here is where it starts. To me, this is where it starts making more sense. So what I'm going to do, let me get this print in here. So you see how all of these are right here. So how about let me do this. We're going to use the license idea, and we're going to jump into the practice file. And this is Jane Q. So that's Jane Q. Okay. And now what we have is we have the class, which is D. I'm just grabbing some of these values. Our height, HGT, and we can do 5. Is that 5, 6?
Yeah.
There we go. 5. (5'6"). And then is that helpful? We run this. We're effectively turning this license into a dictionary with these values. And you can go through and you could add every single one that you want to, and you can see I've done all text here. We'll add weight, but instead of putting the pounds in there, we're just going to assume that it's pounds. So as you see, you could have an integer in here. So your values can still have different data types and that sort of thing. Any questions there, or clear as mud?
Yeah, clear as mud.
So this is the definition of this. And it does show in here that you can define an empty dictionary by just putting the 2 curly brackets. And if I run that, it'll just give me the 2 curly brackets back. This is the so we're defining in this, we're adding the values. We're starting the dictionary out with the values. So how you access them is you access them by the key. So let me comment these out so we can see how that goes.
So you'd call for class and then D or so forth. Or
we're just looking for class. And now keep in mind that we have to add we call the class,
And then value.
excuse me, like the string that it is. You see how this class is a string. So you want this to specify as the string, but this is how we get the value. So when I run this, you see how
Oh, it gives you everything.
it gives you D.
Okay.
Yeah, so if I want to get the information from class, then I call it similar to your index notation, but dictionaries don't have indexes, they have keys, so you put your key in your notation.
Got you. So the key would always be in like quotations, so that way you're able to like kind of index it.
Let's see here. I believe it should be. No, it needs to match the data type. It needs to match the data type. So we used an integer here with 1.
Yeah.
So I have to match that here. So if I try to access a 1 string, see how that key does not exist?
Because it's not stored, so you'd have to go by class.
Well, I tried accessing this 1, but I put it in as a string. But this 1 here is not a string, and it's an integer. So I could have a string 1. Let me show you.
I
This
get
is
what
a
you're
good
saying.
example.
That's what I was gonna say. So if you put it as a string, would it call it?
So which answer do you think I'm going to get here when I print this?
Probably. I want to say a different test, but I also want to say, yeah, I want to say different test.
Now, why is that?
That part I don't know. I would assume because it's a string.
You're exactly correct. Because I referenced the string. And just like Dominic has pointed out, test is an int. To get that one, I have to give it an int.
Okay, yeah.
All right.
See, I'm getting the hang of this slowly but surely.
So this is a mutable data structure. So we can also change it.
So effectively here, you're just renaming the value to call the same information.
Yes, I'm changing what is in, I'm changing the value inside the key. So that's what you see where this starts to become really handy. If in this particular case, we used a dictionary to hold all the information or the information we care about in this particular license. So you could create a bunch of dictionaries if you were dealing with a bunch of licenses or users or stuff like that, because you could have somebody's first name, their middle initial, their last name, their address. They could all be stored in as keys.
Kind of crazy comparison, but this is what I would imagine that like probably a police cruiser's laptop is like coded with when they run a license.
Yeah, it could be. It could be because that stuff is probably going over the internet and it needs to be crammed down into an easy method to be able to get it across the internet. And this is not the subject of what we're talking about, but this data structure really resembles the way a lot of that data is put together to be able to send across the internet as small transmissions, so it's fast.
Sure.
And it still makes sense because it breaks down like this. This is another place where print was needed. Any questions there? Yes. Yes, Laramie, I was talking about JSON. But we're not going to dive into that. This is interesting. Oh, it's because I didn't push the button. There. So Josh, you're asking when I changed the class to DM, it printed out both D and M because I printed it out beforehand. So if I comment that out, oh, yes, if I comment that out, then it gets rid of it. So what I did was I printed it out before I modified and printed it out after I modified. Sometimes we use examples like that to be able, so you can see the process of what was in there before and what was in there afterwards. Okay, so here's another thing you can do. Your values can also be lists. So in this example, what they're doing, let me put the print on this. They're setting the hello key to the list, which contains 2 elements. Everybody see that? So we have these 2 elements updated right here. And then when I run this, just as we covered with lists, you access the list by the index to be able to get your first element. Index 0, first element of the list. The list is the value for the key hello. Everybody see that?
So even though it's like technically the first word, like where I'm like my head's at, I guess, is like when I think about the index, I'm thinking about like 0, 1, 2, 3, 4. So you would be called like how you're putting this as calling for bonjour because it's 0 in the index.
Yes. And I know that's a list. I know
Okay.
the value is a list. If I get rid of the index, I get the list itself. I get the whole list, you see?
Do it one more time.
Okay. So I'm going to put this back the way it was, not 90. There. So we've established it accessing the first element is done this way. Dominic points out, yes, if we change it to 1, we
You'll
get
get
the
salute.
second element, salute, right? But if we
So forth. If you go 3, you'll get world.
No, world is a key.
Okay, so
World
just
and
what's in the brackets.
that's what I was just going to show you. If I get rid of the index and then I hit play, I get the whole list. If I put 3 on there, I would have gotten out of index error.
And you're getting the whole list because it's not defined as to
Well, it's
what you want out of the index.
what right here was where we changed this value to a list. So we changed hello to a list right here. And when we created that list, we only gave it 2 elements, 0 and 1.
Okay.
So that's it. That's what this is right here. So if we tried to access an index that was not in the list, then we would get an error. That's what I meant. If we used an, yeah, because it doesn't exist.
Yeah, my terminology's off, but that's like
No
the way
worries.
right now.
You can use the del keyword to be able to remove an element from the list.
And you would do the same here. Like if you wanted bonjour gone, you would just call for 0.
Well, here you would just call hello. Or, well, del won't work in that example because del doesn't delete anything from a list. We're deleting the key.
Understood.
Yeah. So if you wanted to manipulate the list, you have to think about the list methods.
Okay. So basically what you would be doing by deleting that is deleting that whole block of like bonjour, salute, thank you, merci,
No,
goodbye.
there was a key called world. So let's go back up here. Where did it define it? Right there. So right there is world, right here.
Oh, I see you.
And that's the key we deleted.
Okay, so just get rid of Monday.
I don't speak French.
Me either.
Any help there, anybody?
But that's what you would be getting rid of.
Yeah, so you see world is here.
Yeah.
World is here. And then when we run the del command, it's gone.
Gotcha.
Or the del function. Our list is still here because we didn't touch hello. The way we access this is we go by hello. Like we did here. But if I wanted to do something like, if I went append, if I wanted to add something to the end, I could append let's see if this, yeah. So try it that way. Oops. There. And then, oh, we removed world. Hold on. Me. There. Sorry, that was we had removed something below and then, but you see how I started accessing the list method?
Yeah.
Because when we print, when we access this key, it's a list. So then we can start doing things to that list if we wanted to.
So if you wanted to like append a different word, would you just index the number in front of append?
No, so the index, each one of the values is a string, and that's where I ran into my issue is because I was trying to, if I try to do this, if I try to put the index number and I run this, it gave me this error right here.
String has object has no attribute to append. Okay.
Because what is sitting in index 0?
The key?
Bonjour is.
Oh, bonjour.
Just the word bonjour is sitting in this location, and it's not a list, it's a string.
Yeah, this is going to take me a few times playing with for sure.
I could use I could use a string method here though and call upper. And when I run that, because bonjour is a string, does that make sense? And where I'm this is where I'm calling the string, because the 0 element of bonjour is a string, and hello's the key hello, the value there is a list. So if I want to use list methods, I can't put an index there at all, unless there's a list sitting in that index, but that's getting more complicated.
I get that. What would that the upper value do? Like what is the point of putting the upper value at the end?
All we did was capitalize what was in there. See ya.
Oh, gotcha. Yeah.
Yeah,
It's
and that's
it's hard for me to memorize everything, but like when you say it, then it like correlates.
it's because that is a string, so I can only do string things to it.
Sure.
Yeah. And you could easily do like, this is not going to work because it's a print. It's going to return none. But if I wanted to, change the string, I could do that here. Let me get rid of the print so that,
Instead of bonjour, it's gonna print something.
yep, it would replace bonjour with something
Understood.
because we're reassigning it here.
Yeah.
It gets tricky because you're thinking about it from the dictionary point of view instead.
Yeah, but when I see that equal, that's when I know something's being reassigned.
Yeah.
Okay.
Okay. But that kind of goes to show you can still access the methods by diving into it this way. It depends on the situation, but you may find the need to do that here and there. Maybe you have maybe you have a key called classes, and you have a list of the classes someone's taking, and you want to add a class to their list. You would do it, or you could use the append, or if you just wanted to change the class, you could do it this way. So there's a couple of use cases. When it comes to dictionaries, it's easier for me to think of examples because I use them a lot more. Okay. Any questions so far? I'm just adding some print statements here so we get.
The list still print.
If you don't use the key, you get the whole dictionary. If you try to, the question is would the list still print without the key? So
Yeah, you showed that
if
example.
if I took this out, but I left the index in, I would get an error because you cannot index dictionaries. Does that help, Dominic, or is that the wrong answer? Or is that not where you're going with your question? If I delete hello, if I delete this key, if I delete the hello key, that deletes the value.
Yeah.
So the list would be gone. So when you delete the key, you remove its associated value. Okay, so here's a couple methods to help you see. Dot keys will list out all of the keys that you have in your dictionary. Dot values lists out all the values, and you can see this first. Now, one thing to pay attention to, these are list-like objects it's returning. You see that? So you can actually access those by indexes if for some reason you need that. If you're trying to find like the last key, then you could try to do it this way, but always remember dictionaries are not ordered, so this may not come up. It may not
You would have to call like know where that specific one was in the
Well,
key.
it's not it's not always in the same place, and that's the
Uh,
tricky part there. A lot of time when you use the dot keys is when you are using loops, which we'll cover on Thursday, Wednesday, and to iterate through a dictionary. And we
is
will
there any
go over
is
that.
there any way to call for a specific like value in a key?
You call it by key. The only way to reference stuff is looking for stuff by key inside a dictionary.
Okay.
Yeah. So you need to know what your key is. So generally what you do is you design your key, your dictionary, kind of like a record. So like in the license example, your keys are the things are the blocks that is going to be on every license. Like there's an address, there's
So
a
you would have to
state.
pull the whole thing effectively to access one piece of information.
Yes, and it's not that hard, but it's not as hard as that sounds. I mean, when when you're accessing this stuff, you usually know what your keys are. So you know what data you're looking for, but you're trying to get the values for those. So like if you designed your program, you've got your dictionary there, and then you load in a bunch of CSVs with everybody's information to build yourself basically like a very simple style of in-memory database or something. And then you can go through and you can check everybody's sex, or you could
Yeah.
check everybody's height, and you could actually do whatever your program logic needs to do based off of that stuff. Because the way you've got your dictionaries is it's it's formulated kind of like a record card in a way. And your record
Yeah.
card has all of the same columns, and you're just looking for the data in each column.
Yeah. I mean, I don't want to like make it sound like I was overthinking that. I was just
Oh, no
curious
worries.
all value out of it or anything of that nature. What is a CSV though?
Comma separated values. So kind of think very, very, it's similar. They look similar to Excel sheets, like spreadsheets or whatnot, but they don't have all the functionality as a Google Sheets, Excel sheet, or anything like that. But CSVs are very common in programming. We're not going to touch them here,
Okay.
but you'll see them in a lot of different things. I mean, a lot of the programs you've got, you might be able to look inside one of the directories where your program data is, and you might see CSVs in there. If you see a CSV in there, you can open it with a text editor or Excel or something like that. Excel will make it pretty. A text editor will jam that stuff all in one line with a bunch of commas, and each record would be on each line.
Understood.
Okay, so we have keys, values,
Items.
items, I believe. Okay, this is a list. This returns tuples with the first element is the key and the second element is the value. So you have
So,
three different ways you can iterate through the dictionary.
so essentially all this is doing is like with the license example, it's like if you had the sex, height, age, and everything like that, it's going to pull every single one in this format.
Yes, it's going to bunch them like this. And this could be, yet again, a lot of times this is used for iterating through it so that you might be trying to change information. You might be trying to do like something like, I want to count all the males that we have, or something like that.
Gotcha.
Okay, so here's some dictionary methods. You'll see that just about every data type we've got that we're dealing with has methods. So there's generally things that you can do with them. Get is a little bit different than just accessing the key. Get adds the ability that if the key is not present, so where is our J and Q? We're gonna print, nope, J and Q get, and we want age. So in this particular instance, we don't have the key age. So what we're doing is we're giving it a default value if the key doesn't exist. Does that make sense? Any questions on that? Pop works the same way, but with pop, we're removing the key and returning the value. So we don't want to just discard it. We want to do something with it, but we also want it out of the dictionary. Pop item. That removes a random key value pair. This update, with update, that's a little bit different because you would give it another dictionary, and what you're doing is you're merging two dictionaries. Now, the keys in a dictionary are unique. They cannot have duplicate keys. So in this case, where if we tried to merge two dictionaries that had the same key name for one variable, it would take whatever the value is from the other dictionary in here, and replace the original dictionary's value with that. Does that make sense?
So it would take the second dictionary's key.
It takes the key value pair from the second dictionary. It'll overwrite the origin.
Because technically the second one would be the updated one.
Yes, Dick 2, the other dictionary overwrite. Yeah, I know, I'm trying not to. I hate that. Dictionary 2 overwrites what's in the original dictionary. All right, so, and then the clear method empties everything from the dictionary.
Is there a way to recover it if you if you call
It's gone.
for it?
Nope. You've got to repopulate it. So you just comment that line out, rerun the program.
It's clearing the cache on the RAM.
It's not really clearing the cache on the RAM. It's unassociating those values. So
it just goes from being stored.
It gets a little tricky when you start trying to deal with the unsafe operations accessing the memory addresses. No, in this particular case, it's gone.
Is that not a thing in Python, like where if you have something stored and like let's say you clear, you can't recover. You would have to then populate again.
You can't do it safely. Accessing the old memory address, you would have to. There's no such thing as a recycle bin.
Yeah.
But certain if you reassign immutable types, if you reassign immutable types like we used with the string, you remember the example from the first day where we made name equal to John, we got the ID, the memory address for that, and then we changed what name equaled to, and then I used an additional library to reference the old memory address, and it was still there. So that works with immutable types. Dictionary is a mutable type, so when you clear it, it's no longer in memory. It just dumped it because
Gotcha.
it's still in the same warehouse rack bin. So the
Gotcha.
difference is with the string, John was sitting inside a rack bin that still had an ID, but nothing pointed to him. So there was
That was
no easy
immutable.
way to
So
get to him.
with the dictionary, it's immutable.
No, other way around. String is immutable. A dictionary is mutable, so you can change the dictionary. It doesn't create a new one. It keeps changing what's inside it.
Gotcha.
Okay?
Yeah.
Uh,
See, Dominic, it wasn't that bad.
yes, clear wipes it completely because it's mutable and it doesn't if because it's working with the same memory address. It's the same memory location. Not in this particular instance. You cannot
No.
access it because it doesn't have a different we were able to access the other string because it created a new string. And what it does is when it removes that reference to the old string, the garbage collector eventually chucks it out. Yes, mutable is white completely. Immutable is still there, but we don't know how long, and it's not recommended to try to access that stuff.
Well, I mean, just for giggles, I mean, what would happen if you try to access it? I mean, what is the byproduct of that?
Oh, um, we've overstepped break by like a half hour now, so uh, we can take a 10-minute break and we can keep talking about this here. So let me pause this real quick.
I mean, I'm as comfortable as I'm gonna get. I don't need a break.
Oh, that's my screen sharing paused. All right, so any questions on how clear works? I know we were talking a little bit about the memory and some of the stuff going on behind there. We've got a few examples of how these are running here. I think we've already seen this when we tried to access a dictionary that didn't have the key value or the key that we were supplying in here. And this would be the actual error. Here's our get with the default not found. Here we are. Okay, we have to add some of these prints in here. So do you see what it did here with the pop? We took the result of what the pop method did, pulled out, and we assigned that return value to hello popped, and when we print it, we get the list that we had. That makes sense to everybody? And then when we check the dictionary again, all we have is the thank you key. Any questions on dictionaries? I know there's quite a bit in there. Here's an example of the update function, update method. So now we took the new English-French dictionary and we added it into the English-French dictionary that had the single key. Oh. The reason why this printed out everything is because I already ran the update. Does that make sense? So there are some common functions. There are some common functions we can use on a lot of the on across most data structures. I believe we've seen a lot of these before, correct? The max min, these max min sum. We did len, right? Have we covered length and sorted? Let me know
I
if
re
any of these look
I
new.
remember Lynn, like the Lynn, like how many characters, or it counts the how many are there.
Yes.
I don't think we went over that. I mean, unless it was.
Okay, so let's go with one common. Okay. One common use. We're going to go with the list first. We can use len with list, and that will give us how many elements we have in the list. Now, the same token, we can get how many key value pairs are in the dictionary. Does that make sense? So in a string, each character is element of the string. So that's why we can find out how many characters are inside the string with len and whatever our string is. So it counts out each character because those are the things we can iterate through. Inside my dictionary, we can iterate through the key value pairs, each element, which is separated by a comma. Same thing for the list, we have each element separated by the comma. Is that helpful? Does that help clear things up, or do you have more questions on that, Josh? Naturally, we know we can only do some with numeric values, but we can pull a max off of a string. I believe we tried that before, right? And it gave us the closest letter to Z. You could do the same with min. And it's the space. I don't know. I don't think there's very much value in using min or max on on characters themselves, but strings, when you have like multiple strings in a list or something like that, you might be able to find the longest string that way. Or the longest string. That's a little tricky there actually, because that's not just going to take the longest string, it's also going to have the most letters that are closest to Z. Does that make sense? So these have same amount of characters, but I have a Z in one of these. If I go change it to an A, so It's not super useful. So if you're looking for the longest string, we would most likely be using a combination of the len and loops, which we'll cover on Wednesday. I believe that's definitely one of the. It's a very common problem, so we'll most likely either cover it, it'll be on one of the assignments, and we can easily walk through that sort of logic. Any other questions with it? Any of these common operations? And there's more than these. It's just these are used a lot. Pretty sure we covered sorted, correct? Now, remember, sorted does not change the list. It creates a copy of the list, which is sorted.
So it would just basically print what is already stored.
Well, in this example, we have collection. So if I take and mess this up, and let's comment this out, and we go print my list. And then what we want to do is we want to print sorted my list. And I'm going to print my list again.
Oh, so it's just going to print it in the original stored value.
Yeah, that's something we want that's something we want to use when we don't want to modify the original list. So if we were for some reason using it to do some sort of side temporary processing or something, but the original list order is in that order for a reason, then we basically create a copy and we modify that copy. We do all our processing based off that copy and leave the original list alone.
Gotcha. Makes sense.
And remember, we can do you can reverse it. And that's pretty much most of the operations and the key concepts behind these two data structures. Any questions?
That's pretty simple.
And as before, it takes getting your fingers in, playing with the stuff, and just you learn by getting in there and doing the thing. Basically, you can read
That's
about it all day long.
that's exactly what I was going to say. Like I get the like a pretty good warm and fuzzy from it, but then like once I get into like the meat and potatoes of it and I'm having to like play with it, that's where I'm like, oh, okay, this makes sense.
Yeah, and that's the key. All right, so that's the end of the topics we've got for today. If there's no more questions, I'm going to go ahead and end the recording. All right.